Hello and a big warm welcome to this presentation from Pluralsight. My name is Andrew Mallett and I'm going to be your instructor to help guide you through the module Working with Containers. Now, with all that in mind, what exactly are we going to be taking a look at? Well, we'll be taking a look at containers, but primarily we'll be looking at the Docker Container Engine. We'll be comparing our containers versus virtual machines. We'll be taking a look, as I say, at the container engine Docker. There are other container engines available, but Docker is available to us on Ubuntu 20.04. We'll be taking a look at Docker images, Docker containers, volumes, ports, as well as the Docker file, which can be used to create images. So if this looks interesting to you, why don't we take a start? And we're going to begin by taking a look at what containers are. Containers become a way that we can separate our applications from the operating system. No longer do we have to worry about installing the application on the operating system. We can install it in a container. Now, this can be really useful. Very often we get a problem where application 1 needs a certain version of a library, whereas application 2 requires a completely different version. But being able to isolate our applications means that we can run both of those applications concurrently on the same machine. To see how that's going to work, we start off by looking at our hardware. This is obviously the hardware of our host operating system. On top of this, we install Docker, which gives us the Docker service. The Docker service is used to manage our containers. Our applications then are installed into containers. So Docker runs application 1, application 2 container, application 3 container, application 4 containers. Now, all of these applications can be completely separate, or they can be very similar applications requiring a different version of a Java virtual machine or requiring a different version of a standard library. But they can coexist on the same machine because each container has everything that the application needs to run contained inside of the container, and they're isolated from one another. Now, to install Docker, it's really easy on Ubuntu 20.04. Docker is part of our standard repositories in Ubuntu 20.04, so we can make sure that we've got root privileges. And one thing that we might want to do is check our network cards, because we're going to get a virtual network card that is added in during the installation of Docker. We can make sure that we've got the up-to-date metadata, installing the package docker.io, make sure that it is docker.io. We've got a back-end service, so we can check the status of that service. It will be running. And then going back and checking those links, we should see that we have a new Docker 0 network card that's installed. We can go and check our Docker version. There are different ways that we can do this, but this is a simple check that we can run. And we can also get more information about the containers and the images that we have using Docker info. As a simple test, we can go and run the Hello World image. This will pull the image down and create a runtime version of that image known as a container. Now, the best way for us to learn is for us to dive out through to our command line, and I always strongly encourage you to work along with us. We will need Ubuntu 2 up and running, so we're going to be working on our Ubuntu 2 20.04 system, and we're going to ensure that we've got Docker installed, and then use the Hello World image. Come on, let's find that command line. Now, look at this, our glorious Ubuntu 2 system that's up and running. Now, remember, though, I was saying one of the first things we might want to do is check our network cards. So I'm going to run ip-link ls, and we can see then that we've got our loopback, and then we've got 2 other physical network cards installed in our virtual machine here. We're checking this because as we go ahead and elevate our privileges, we can then go through and install our docker.io package. And installing it, it's going to add in an additional virtual network card. So as we then run through, just accepting that we're going to install it, we can allow it to do all of its hard work. But included in that hard work, it's going to create ourselves that new virtual network card connected to the Docker network. Once it's gone through, we should be able to check all of this. So if I now go through and clear my screen, and if I look at the IP link ls, look at that, right down the bottom there, we've got Docker 0. See, I wasn't lying. Now, we're not using that at the moment, but we can use that for our Docker networking as we start looking at different elements of Docker, but just to point out that it's installed by default. Using Docker as our container management system, we do have a backend service, so systemctl status and Docker, and we can see that our Docker container service is running in the background. When I look at the version of Docker we've got, we can use ---- version, and we get a quick and simple version of this coming back. But I can also go through and use Docker version without the --, and we get a little bit more information coming back. So there are a couple of ways that I can get the version. Another tool that I can use, though, is Docker and the subcommand info. Now, this gives me quite a lot of information, and it is worth going through, but perhaps in your own time. But for the moment, I want to look at the top of this output. So if I pipe it through to head, we can see then that I don't have any containers and I don't have any images. That's about to change. Let's take a look at how we can download our images and create runtime containers from there. With our Docker command running as root, we can use Docker run and then hello-world. This is making reference to an image. Now, we don't have any images at the moment, so we're going to search for it. We won't find it locally, so we will pull it down from an image registry, so we can see that we are pulling it down. The image then downloads and creates a container. The container runs its executable, which just displays this message. Once it then has executed, the container stops itself. So now I will have an image in the container, but the container won't be running. Going back, reading that information, we can see then that I've got one container, but it's stopped, and I have one image, and the image then created our runtime container. Now, of course, we do need to understand the idea of our images and how we manage our containers, but this becomes a very good and simple way to prove that Docker is fully up and running.